Well, good afternoon, everyone. I am Rogelio Escobar, the coordinator of the Behavioral Sciences Department of the School of Psychology of the National Autonomous University of Mexico. Thank you all for joining us. Today, I am honored to introduce the talk of Dr. Florent Buisson. Dr. Buisson is a behavioral economist with 10 years of experience in business, analytics, and behavioral science. He most recently started and led for 4 years the behavioral science team of Allstate Insurance Company. Dr. Buisson has published academic articles in journals such as the peer-reviewed Journal of Real Estate Research. He holds a master's degree in econometrics as well as a PhD in behavioral economics from the Sorbonne University in Paris. He recently published the book Behavioral Data Analytics with R and Python, that has rather impressive reviews by diverse organizations focused on behavioral data science. As an example, this is the review of the president of BE Works Research Institute. He noted, "We are awash with data, and this is a long-needed resource to guide practitioners in using that data for building valid causal models to predict and explain real-world behaviors." Before leaving you with Dr. Buisson, I'd like to thank Pablo Lagunes and Dr. Germán Palafox for proposing this talk and contacting Dr. Buisson to make this talk possible. Well, thank you, Dr. Buisson, for accepting the invitation and connecting with us today. Thank you.
Yeah, thank you very much for the invitation. And the behavioral science world is a small world, and it's a pretty nice world, and we really try to take care of each other and share information and advice, because we really want this small world to get bigger. So today I will talk, like I said, about, as the title says, about data analysis for applied behavioral science. So let me screen here. So just to elaborate a little bit more on the initial description. So as mentioned, I have a PhD in behavioral economics, and then over the last 10 years, I've had a career that has spanned business consulting, analytics, behavioral science, and then since earlier this year, kind of the conjunction of all of that, working as experimentation principal in e-commerce. And so I've really had the opportunity and the time to think through how can someone who has a degree in behavioral science enter and be successful in the behavioral science field. So that's really kind of the angle I want to take today, is that. So this is a screenshot of behavioraleconomics.com, which is one of the main job boards for behavioral science and behavioral economics. And there are more and more opportunities. When I finished my PhD, I went directly into business consulting because there wasn't really such a thing as a applied behavioral scientist in business back then. But now there are more and more opportunities, and also a lot of opportunities at the frontier between behavioral science and UX research or design. And so for someone coming with, say, a degree in psychology, cognitive sciences, human factor, behavioral economics, this is a very exciting time to join the applied behavioral science world, whether on the business side or in one of the government or international institution agencies. So for example, you cannot see it on the screen, but a bit lower in that list of job posting is one for the international refugee committees. So there are really a lot of opportunity to apply a behavioral science background to very interesting question whatever your interest is. And so my angle today is that, well, if you have, again, say, a master's degree or a PhD in psychology, and you want to enter the world of applied behavioral science, or maybe you just got hired as an applied behavioral scientist, what data analysis tool do you need to do your job? So that's really the question I'd like to try to answer today. And I will open with a warning that, well, if your boss is a behavioral scientist and tell you to use certain tools, then you should definitely listen to them and do what they tell you. Here, this is just my personal opinion of how to best answer the questions that you may receive from your business partners or your client, and how you can best analyze the data you have at your disposal to answer the business question. And so, to give you kind of a bit of an outline of what I'm going to be talking about, so the first question, which I've had from many students, is, do I need to learn data science? And to give a quick answer, no, I don't believe that you need to learn data science to be an effective applied behavioral scientist, but I will elaborate a bit more on what I mean by that, and then I will expose two other directions that I think are much more effective and fruitful than using machine learning predictive analytics, which is what I think of as behavioral analytics and causal analytics, and we'll see how they come together. And then in the last part, I will talk a bit about how I don't really believe in statistical tests. I was trained and groomed in econometrics. I have a degree in econometrics. I know how to run tests. So but I just don't believe we should. And I believe that there are methods today that are much more effective at answering the question from our business partner. So with that said, let's dive in. So do you need to learn data science? And to answer that question, I will first need to get into some distinction. And so the traditional distinction that we make in the area of analytics is between descriptive analytics, predictive analytics, and causal analytics. Descriptive analytics provides, as its name indicates, a description. And the way I think about it in like easy to understand term is what is or what has been. And so it tells us about relationships and correlations that we can observe in the past. And so, for example, descriptive analytics might tell you over the first half of the month, among our customers, we saw that younger customers purchased less meat than older customers. We saw that consumers in the north of Mexico have more of a preference for this product as compared to consumers in the south part of the country, and so on. And I do want to say that I think that descriptive analytics is often undervalued and kind of really neglected, but I do think that having a clear understanding of what has been can be really powerful, and I'll get back to that a little later. The second big pillar of analytics is predictive analytics. And so predictive analytics gives us a prediction about what will be if the future is like the past. And so it's kind of, in a sense, a projection of descriptive analytics from the past to the future. Is, well, in the future, if things are like in the past, if we have younger customers coming on our website, we expect that we predict that they will purchase less meat than older customers. if the future is like the past, we expect that consumers from the north of the country will behave this way as opposed to consumers from the south of the country. And I'll speak a bit more about predictive analytics in the next slide, because it's really what constitutes really the core of data science. But first, I want to get to the next level of what I think is really where the most important part is for applied behavioral scientists, which is causal analytics. And the difference between predictive analytics and causal analytics is that, well, in both cases, we are making a prediction, but in the case of predictive analytics, we are assuming that the future is like the past, whereas in the case of causal analytics, we are exploring what would happen if we did this, if we did that, if this thing changed, what would happen? And so causal analytics is actually very powerful, as we'll see. So to talk a bit more about predictive analytics. So predictive analytics is really what people usually think of when they talk about data science or machine learning. And so when you hear people talking about algorithm like random forest, XGBoost, neural network, and so on, those machine learning algorithms are really kind of the pillars of predictive analytics and of data science. And those algorithms, usually they are used with a large number of variables, and so it's pretty common to have models that have dozens or sometimes hundreds of variables that are used to make predictions that are as accurate as possible. And so the idea is, well, how accurate can I be at predicting what consumers who are like the consumers we had in the past will do? And so a typical example is with retention models. So you have customers who have, say, some loyalty card or have some subscription, and you want to predict if those customers are going to remain your customers or if they're going to leave you for the competition. And so what you try to do with predictive analytics is really to predict who's going to live, who's not going to live. And you can think of it as a crystal ball that tells you this person is going to live, this person is going to stay. And really, you want that prediction to be as accurate as possible. And you don't really care about the y or the relative weight of variable. And so some of the issues and the limitation of that approach from a behavioral perspective. So one aspect, one limitation is that it kind of takes data as true. It's like, well, it really believes that in a sense, data is a transparent reflection of the world, and feature engineering, which is just a fancy way of saying changing variables and creating new variables, feature engineering is used only to increase the accuracy of prediction. If you transform two variables into a new variable and your prediction is more accurate, then that's a win, regardless of if the new variable means something or is completely meaningless. As I mentioned, the second aspect of predictive analytics that can be problematic from a behavioral perspective is that it assumes business as usual. And more precisely, it does not account for business action. And so if you think about the retention model that I mentioned in the previous slide, at the end of the day, even if we had a perfect crystal ball that would tell us with 100% accuracy, this person is going to live, that person is not going to live, that would actually be of limited interest to the business, because really what the marketing managers care about is not really who's going to live, but who could I retain if I take action? How can I take action to retain my customers? And that is one area where predictive analytics is essentially silent and does not tell us what you would have to do to get there. And so from that traditional distinction between descriptive, predictive, and causal analytics, the way I have come to think about how a behavioral scientist should do data analysis has been what I've called the causal behavioral framework. And that is a little bit of a mouthful, but really it's not so much a formal framework as it is a mindset, a way of thinking about our data analysis. And what I mean by that is really kind of thinking about each of those 3 arrows. How do the behaviors of my customer are reflected in data? That's the arrow between behaviors and data. How are the behaviors of my customers affected by other causal factor, and how can I represent the causal factor that impact those behaviors, that is the relationship between behaviors and causation, causal analysis, and especially one tool that I will call out is causal diagram. And then finally, how do this causal diagram represent the relationship between the variables in my data? And so really what I want you to take home, like really today, like really I think the biggest core argument of my presentation today is that to be a successful applied behavioral scientist, what you should do is think about the interaction between those 3 things. The behaviors of consumers and employees and customers and so on in the real world, the data and causal relationship, and how those 3 things interact with each other. That is really what I think is the core idea I would like you to take home. So, but what does that look like in slightly more concrete terms? So the first area is really like in the diagram, if you think about the arrow between behaviors and data, this is what I think of as behavioral analytics. And behavioral analytics can really give us some deep insights, even while staying in the realm of descriptive analytics. So simply taking a behavioral lens, a behavioral perspective on your data can be extremely useful even without using any algorithm. So one phrase that you may have heard is that data is the new oil. And so really the idea that data is the new source of wealth and riches. And to build upon that metaphor, I would say that data is the new petroleum. It's the new raw crude oil. It is not the refined car gas that goes into your car. It is something that really need to be refined and not just cleaned up. So if you think about the metaphor of cleaning up data, the idea that, well, you have data and there's some dirt and you just need to remove the dirt. But apart from that, the data in itself is good. Whereas if you think about data as petroleum, then that is something that you need to refine, that is something that you need to transform so that it is helpful. And the first reason why you need to transform your data is that databases reflect the logic of business processes and not behaviors. And so I'll give you an example, which is imagine the simplest example of a marketing email. You have a marketing manager who is sending an email to customers to encourage them to place an order online. Or you have an agency, an international development agency that is encouraging people to go get tested for HIV or register themselves to vote. And so that is and I'll stick with the marketing example first. So now imagine that you have a customer who receives the email, use the coupon in the email to place an order, but then the product that they ordered is out of stock, and so the order is canceled. So from a business perspective, it completely makes sense to cancel that order because from an accounting point of view, that order essentially did not happen. That is, there was no product shipped. The business does not receive any money, does not keep any money at the end of the day. So it makes sense that in the database, that order would be canceled and removed. But from a behavioral perspective, the email was actually successful at driving the behavior that we wanted, which is we wanted that person to go and place an order. And so really, from a behavioral perspective, when you want to measure the effectiveness of the marketing email, it doesn't matter whether the product was in stock or not. What matters is whether the person took that behavior. And same thing with getting someone to go to a clinic to get tested for HIV, but then the clinic is closed. Like in both cases, you have factors that are outside of the behavior of the person that happened. And so you really need to think through what is the behavior that you want to drive. And the way I think about it, and I encourage people to think about it, is if you were in the room with the person, or if you were like observing the person with like binoculars, what would the behavior look like? And the behavior is something that you should be able to see with binocular or by looking over the person's shoulder. It's something that happens in the real world. And there are many ways in which taking this real world perspective and transforming the data can really help us make more effective data analysis. And one other example that I have encountered many times is categorical variables. And categorical variables can be tricky because they feel intuitive, like, oh, people from the north of Mexico, people from the southern state of Mexico. And you're thinking, oh, well, I kind of have those ideas of association and it feels intuitive, but that is not really actionable. And so really, it's in many cases, it is more interesting to replace categorical variable for numerical variables that will tell you why this has happened and why that category is different from this other category. And to wrap up this slide, one example that was really tricked me was around business default. And so, for example, if you are automatically enrolling customers in paperless billing so that instead of receiving their bill in the mail, they receive an email for it, then it doesn't make sense to say that you want more customers to enroll in paperless billing, because the only people who do not receive in paperless billing are the people who went into their online account or called customer service and opted out of paperless billing and said, no, I do want to receive a paper bill. And so trying to make those people aware of paperless billing is not going to be helpful, because they are aware of paperless billing and they went out of their way to cancel it. And so really the behavior is opting out of paperless billing, and thinking about that concrete behavior is going to be much more helpful than thinking, how do I drive up the rate of enrollment in paperless billing? And so that example from the field leads me to a typology of how to think about behavioral data and how to think about behavioral variable. And so the key idea here, from my perspective, is that in business or in applied setting in general, there is often some confusion and the idea that, oh, if we know that women do this more than men, or younger customers or older customers, and that is helpful. But the problem is that demographic variable, personal characteristics, are very often not actionable in themselves. And so having a clear model of how humans behave can be really helpful in your role. And so the model I have here is probably a model that many psychologists or cognitive scientists would disagree with, and it's just a model I made up, but really it's just a model I have found useful in my work, because it really allows us to distinguish things that are personal characteristics and that are not actionable. It's like, well, it might be useful to know the personal characteristic of the person, but in itself, it is not actionable. What we cannot make people older or younger simply by acting on them. What is actionable, on the other hand, is cognition and emotion and intentions. And psychologists would probably say that, well, intention should fall under the umbrella of cognition and emotion. But in applied behavioral science setting, we very often try to have different action. We have different intervention to try to change cognition and emotion. So are people aware of our offer? How do people feel about our brand? And then we have intention. Purchase before it's too late. Redeem that coupon. And so from an applied behavioral science perspective, separating cognition and emotion on the one hand and specific intention on the other hand can be very helpful, because that allows us to really see the intention-action gap. And did people have the intention to take the action we wanted them to take and something went into the way, or did they have the right cognition and emotion, but they just did not translate that into an intention? And so having this kind of a framework to think about what the variable in our data reflect in terms of behavioral variable can be really helpful. And so, for example, it allows us to have more helpful segmentation. And so from like, again, I have mentioned, we see very often in marketing segmentation that is based on demographic or personal variable. But really, segmentation in like demographic segmentation in itself is rarely very helpful, because we cannot change people's personal characteristics. The better way of thinking about segmentation is from a mathematical, statistical perspective. Moderation is, well, how does the effect of our intervention change between those two demographics? And so really, that's a much more effective way of thinking about segmentation. And so, for example, you might find that, well, our email campaign was not very successful across the board. Like on average, it was not very successful. But now, if we run a regression where we have an interaction term, so really simply a multiplication term between our treatment variable and a demographic variable, now we can measure what economists call heterogeneous treatment effect, or like what psychologists called moderation. And now we can see, oh, for this group, our intervention was more effective than for that group. And I have found that taking this moderation approach to segmentation and so using variable, the interaction of demographic variable and business intervention can be much more helpful than using demographic segmentation. So really that was, and as I said earlier, I haven't described here any fancy analytical tool. I've just said that taking a behavioral perspective on your data can allow you to get much deeper and much more actionable insights without even using any more complex tools. Simply taking that behavioral perspective on data can be very helpful. Now, the other perspective is around causal analytics. How does cause and effect phenomena are represented in our data, and how do they represent the behaviors we're interested in? So causality is very often a concept that can be a bit complex to use, and so you've probably heard the phrase that correlation is not causation. And so in many cases, it can be a bit complex to think about causality and how it plays out in your the situation you're analyzing. So a tool that I have found very helpful is causal diagram. And so a causal diagram, as you can see here, is really just a diagram where each box represents a variable and or a behavior or personal characteristic. So here you could map that causal diagram to the behavioral type of variable I mentioned. And really what that helps us to understand is in terms of what psychologists will call mediation. Why would our business intervention be successful? And that's very helpful because in many cases, business decisions are not the result of a rational analysis of what is the problem that we're trying to solve, but they are driven by, hey, our senior vice president has read an article about design thinking or agile, and we really need to do this today. Or this other vice president has gotten a call from a very disgruntled and unhappy customer, and so now we need to solve this specific problem. And so taking the time to build a causal diagram can really be helpful to clarify the business logic and really think through what's happening and what we're trying to achieve. So the example here is like if you imagine an insurance company that is considering adding a one-click button to increase sales. And I'm sure that you have all encountered this idea that, okay, direct button, okay, click and bam, you can purchase instead of having like this long journey through 4 or 5 screens. And so that is, in itself, that can be a really compelling idea. Like, oh yeah, one-click button, that makes sense. But the fact that it makes intuitive sense doesn't necessarily mean that it makes business sense. And so really, once you start thinking like, well, what are we trying to do? Well, we're trying to increase revenue. And so it's like, well, we're really trying to increase the revenue. That is our business goal. But what is the behavior that we're trying to affect that will increase our revenue? The behavior we're trying to affect is whether someone who comes on our website, whether they complete a purchase of an insurance policy or not. And so now we have this binary yes/no variable, behavioral variable, which is the specific, concrete behavior of our website visitor that we are trying to affect. And so now the question is, how would our business intervention, which is adding a one-click button, how would that affect whether our visitors complete the purchase or not? And one hypothesis you could make is that, well, maybe a lot of visitors drop off during the process and they do not complete the purchasing process because it's taking too long. That is a valid behavioral hypothesis, and now you're getting into something that is again concrete and measurable, and even better, it's something that you can look at even before implementing the one-click button or before doing any other intervention. You can just look in your data, well, how long is the purchasing process, and do people drop off after spending a lot of time in our website, or they just, no, people come on the homepage, if they don't like what they see, they go away. Well, if that is the case, then reducing the number of screens of the purchasing process from 5 to 2 is not going to help because the behavioral problem is different. And so really having this tool of a causal diagram can really help us think through how what we're trying to do would drive a specific observable behavior that will then drive a business outcome. And one situation I have observed, like I've experienced, was for a company that had a very clunky website. It's like everyone in the company agreed that the website was pretty poorly designed and like it's just been around for too long. And so we're like, okay, let's get the UX team to modernize and simplify the website. And so the UX team built wireframe, did UX testing and really like, okay, the people, when they came to the UX lab and they looked at the design, they were like, yeah, this looks better, this is simpler, this is easier to use. And so like, then everyone's happy, we roll out the new experience, but then there was no increase in sales, and the business leaders were like, well, UX, what happened? And UX, the answer was essentially, well, you told us to make a more modern, simpler, and beautiful website. We made a more modern, beautiful, and simpler to use website, but we never actually checked if the fact that the older website was clunky and ugly and complex, whether that was impacting sales. And maybe people who wanted to buy bought anyway, and people who did not want to buy just went away, and the fact that the website looks better is not going to affect that. And so if the business leader had really clarified from the get-go what is the business logic of the intervention, what is the business logic of this project, it would really have helped clarify, hey, why do we think this would impact purchasers, and what can we do to validate this idea ahead of time? So, and in this particular case, this is a very simple causal diagram, but once you get into the real world, causal diagram can get much more complex. So here you can see an actual causal diagram from a consulting project I led, and so which with the variable blacked out, obviously for confidentiality reason, but that's literally the causal diagram that we used, where the square boxes were the variables that we were observing, circle boxes were the variables that we could not observe, but we thought were intervening, and then we had our A/B test that was represented by the blue box. And so really what we did is that we used a causal diagram as a way to understand the situation and what was driving or interfering with customer behavior. And so building a causal diagram like that is a really great way to get experts from all across the organization to contribute and say, oh, you should take into account this factor or that factor. And then reversely, you can show them the causal diagram that you have at one point in time and say, like, hey, do you agree that this is causing that, and that there is this variable here? And with a minimum of explanation, we have found that a business partner can intuitively understand, like, well, yeah, I do believe that this variable impacts that other variable, and that's why. And so it's a really great way to get everyone on board with what is our understanding of what's going on. And then beyond that, causal diagram allows us to understand which variable we should include in the analysis. So I talk more about it in my book, but really the idea is, what are the variables that the confounders that interfere with our analysis and make it so that we have a correlation that does not reflect causation. So all of that to say, I'm a big fan of causal diagram, and I think that whatever other tool you use, it can be a great way to make your understanding stronger. Oops, sorry, wrong direction. And so, as I mentioned, and I'll get a bit, oops, yeah, I'll get over that one quickly. So as I mentioned, causal diagram can allow us to understand what variable we should include in our analysis. And so that can allow us to make judgment on causal effect. And so really think through, well, what are the confounder in our analysis, and what are the variables we need to include to make sure that what we're measuring is really causation and not just correlation. So keeping an eye out on the clock, let me get to the last section, which is the bootstrap. And so really the last piece, which is independent of the previous one, but I think really goes very well together, is that once you start having like two behavioral variables and you start thinking through causal inference, then what happened is that you will have trouble using statistical tests. And so then, because in business, the only thing that matters is effect size. And so from that perspective, like the null hypothesis statistical testing framework, which is the statistical framework that says, oh, does our data allow us to do we reject the null hypothesis or do we fail to reject the null hypothesis? And this framework, this mindset, was really developed for scientific research. And it's a great tool for scientific research because when you think about scientific research, there are all those things that we know and we're like pretty certain about them. Okay, gravity, pretty certain that gravity exists. And so now if we are trying to run a new experiment, it's like, well, we want to have the burden of proof of like, well, is this thing, this unknown hypothesis, unproven hypothesis, or this new idea valid, or are we sticking with what we know? But that's really kind of appropriate when you have kind of a body of knowledge and you are incrementally adding to that body of knowledge, but the body of knowledge itself remain pretty constant and like stable in time. But in business, there is no null hypothesis because really we're using one design after another and making changes all the time. And so one example is if you imagine that you have a design A that is implemented on your website and you have two competing designs, B and C. So first you do an A/B test, A versus B, find that B performs better than A, so then like statistically significant, etc., then you would implement B. Then you would test B versus C, and the confidence interval for the difference is between -1 and +9 in favor of C. And so now the question is, should you implement C even though the difference is not statistically significant? If you stick with the null hypothesis statistical testing framework, is like, no, we should not implement C because the difference is not statistically significant. But the fact that you tested B before C is essentially random. And so now if you imagine, well, we had tested A, then we had tested C against A, found that it was statistically significantly different, and then we had tested B versus C, the difference would now be between -9 and +1. And so would you implement would you then implement the variable B? No, you would clearly stick with C. And so that means that whether you implement B or C depends on the order in which you test things, which is essentially random. And so from that perspective, I really think that in business, it doesn't make sense to have a null hypothesis and to think, oh, is it different statistically significant or not? You really want to think, what is the effect size and how uncertain are we about the effect size? And so when you have uncertainty, then how can you deal with that uncertainty? Slide. So how we can deal with that uncertainty is by using the bootstrap. And so the bootstrap is a very nice simulation tool where we just kind of simulate some of our data. So if we just pull some data from we resample, formally speaking, we sample with replacement from the original data, and then we run our analysis again. And so you do that again and again, and then you get that histogram of all the values you have obtained that you can see like an example on the right. And then you can just say, well, this is the histogram of the potential effect size. I'm going to remove the 5% of value on the left, 5% of value on the right, and now I have a bootstrap confidence interval. And that bootstrap confidence interval is going to be very robust because one challenge is that very often the assumptions that underlie statistical tests, for example, normality, are violated in real life. And so one typical case is if in your population you really have two different subpopulation. And so you're seeing data and you're like, okay, well, there's kind of one hump here, another hump there. And really that's a mixture of two different populations. And so overall the data is not normal. And so using the bootstrap is really a great way to obtain confidence interval that are much more robust when your data is not behaving as the theory assumes. And finally, the last aspect is that even if you try to use p-value correctly, business partners often misunderstand them, and there's this idea of like, oh, statistical significance is good, so not statistically significant is bad, and they don't really think about the effect size and the possibility of like, well, if you're using a 90% confidence interval, there's still going to be 10% of cases where that's going to be on the other side, on the outside, and so what would that mean for the business? And so instead of relying on statistical significance, using confidence interval built with the bootstrap is a great way to draw attention to the range of possible outcomes, even when your data is weirdly shaped or even when it has a small sample. So one example I give in my book and also in the Medium post that I link below is even with 10 data points, which from a statistical perspective is really very low when you, like any statistical framework will tell you like, okay, don't do anything with those 10 data points. Bootstrap will still allow you to draw some meaningful conclusion. You're going to have a very large confidence interval because 10 data points is not that many, but it's still going to be a meaningful and robust confidence interval. So here's just a quick diagram on when to use the bootstrap. There's more to that in my book. And so to wrap it up, and keep a bit of time for questions. So again, I really think that as an applied behavioral scientist, the intuition that you have built in your psychology science or behavioral economics classes are one of the most important assets you have for being an applied behavioral scientist. And from a quantitative perspective, it's much better to take kind of a causal behavioral mindset where you think through the interplay between behaviors, data, and causation. What are the behaviors that we're interested in? How are they reflected in our data? And what are the causal relationships? And within that framework of causal analysis, using the bootstrap allows you to form confidence intervals that are robust in any situation, regardless of the shape of the data, and to draw conclusions that are relevant. So if that may give you a desire to buy my book, it is available as a hardcover or Kindle on Amazon. It's also available on the O'Reilly platform, and the following code that you can see, and I'll share the slide after the presentation. This code will give you 1 month of free access to the platform, and so will allow you to read any O'Reilly book. And finally, you can also follow me on Medium, where I post, I would not say often, but I have quite a few blog posts about how to think about behavioral data analysis. And so with that, is there any question? So I'm pulling up the chat. So yeah, do we have any question in the room or in the chat?
Okay, do we have questions?
Okay, well, still sticking on. Okay, yep, go ahead.
There's one question.
You said that bootstrap is, well, it works when you have a small sample. How small?
I did not catch the question, so could you repeat the question, please, Dr. Escobar? Yeah. Oops.
Just I can repeat the question here if you. Okay, the question was that you mentioned that bootstrap regression can be used with small samples, but how small the sample can be? Because we sometimes, I mean, I think that's because we sometimes have very small samples.
Yeah, I mean, like I said, I feel I've used it successfully with 10 data points, and basically what you're going to, once you start using a bit the bootstrap, you'll get some intuition and some sense for how it works and what it's telling you. And so really, I would say that it's probably pointless. I mean, logically, it's still gonna work, but it's not going to tell you really much. If you have, I mean, basically, if you're below 5 data points, it's going to tell you, well, 90% confidence interval is going to be somewhere between your lowest data point and your highest data point. And then with 10 data points, you're starting to have something where your sample size is getting a bit more interesting, and the confidence interval is a bit more interesting. And then once you get beyond 10 data point, I feel like as long as you are careful with your conclusion, you can really you can be comfortable that with the confidence interval that you're using. So yeah, basically 10 data point, I have found that 10 data point is perfectly fine in many cases, as long as you're still using kind of common sense about what the conclusion you're saying.
Okay. Thank you. Are there any other questions? No, we don't have questions. One more question.
Well, I didn't, no pude copiar el código promocional que tiene al final. En la diapositiva anterior,
can you please put again the code that you had in the last in the previous slide? They were telling me that they couldn't copy.
Yeah, no worry, and I will definitely send the slide after, and they can be shared. And but yeah, definitely. It's and so as a mental check, so the code is so behavioral data analysis with R and Python, and this is the 2022 version of the code. So that's BDARP22. Behavioral data analysis with R and Python.
Okay.
But yeah, and again, I mean, you can freely share the slide. And if you do happen to read the book for free on the O'Reilly platform, which I think is a great opportunity, then by all means, I would very much welcome any review on Amazon. And for some reason, the number of reviews has trailed behind sales. It's like, okay, the book has been selling reasonably well, but quite a few reviews. So whatever you think of the book, if you can leave a review on Amazon, that will tell me and future readers what they should think.
Okay. Well, thank you very much, Florent, for being here with us today. I'm really interested in reading your book now with all we heard about. So thank you all for coming.
Yep. Yeah, and yeah, thank you for listening. And I would definitely encourage anyone with a psychology or cognitive science background to explore opportunity in applied behavioral science. Like, and I mean, even if like many behavioral scientists, you got into psychology to do good in the world and help human beings and not just make money, which I mean, many people in the behavioral science world got in there through some idealism. There are opportunities with the UN, with international agencies, or in government that are great opportunity to help drive more sustainable behavior, drive more civic behavior, helping with reproductive health. Or so even if you're like, well, I don't just want to help the company make money, few behavioral scientists are in it just to help make more money, then there's a lot of opportunity in the applied behavioral science world that are really interesting and make for a very interesting and meaningful job. So yeah, best of luck to you all, and have a good rest of the day.
Thank you. Thank you very much.